Okay, let's take a look at a heat exchange problem. For this example, we're looking at a piece of aluminum that is brought up to 100 degrees Celsius, then put into a glass cup that has water in it. So the glass cup and the water are going to heat up and the aluminum is going to cool down, and we want to find the final temperature of the equilibrium mixture. So let's first identify both sides of our relation. So Q lost, this would be the aluminum, and Q gain would be the cup or the glass and the water. Okay, so here's all the data for our aluminum. It's got a mass of 0.1678 kilograms, must be put into kilograms. Specific heat capacity of aluminum, and this is the change in temperature. We don't know what the final temperature is, but it started at 100. The water information is right here. So it's 152 milliliters, which would be 0.152 kilograms, specific heat capacity of water, and we don't know what the final temperature is, but we know the original temperature of the water was 17.1. And this is our glass cup, which there's the mass, specific heat capacity from a chart, and we also know that the final temperature is going to be T2, and it originally started at 17.1. So now that we have all of our variables, we're going to start listing or writing out the equation. So for the aluminum, and because we have all of our listed units, I'm just going to drop them for now, just to save some room. So there's our heat lost, and then gained on the other side, and I'm going to put a negative with a great big parentheses so that we remember to do both of these terms. So there's our water and our cup. And our closed bracket. So just squeeze that a little bit to try to fit it all on the screen. So we've got the aluminum, the water, and the cup. So what we're going to do is simply take the two terms out in front and multiply them. So these two are going to get multiplied, these two are going to get multiplied, and these two are going to get multiplied. Okay, so if I take these two terms right here, 0.168 times 910, I will get 152.698, and I still have the binomial of T2 minus 100. And next we're going to go over to this one. Okay, so now if we multiply these two terms right here, we will get 635.36, and we have the binomial T2 minus 17.1 is still there. And finally, if we multiply 0.163 times 840, we'll get 136.92, and the binomial of T2 minus 17.1 is still there. So we've done some simplification. Now what we want to do is collect some like terms. And what we'll notice is that there is a T2 minus 17.1 right here, and there's a T2 minus 17.1 right here, which means these are similar terms, and we can just simply add the 635.36 and the 136.92. So if we add our 635.36 T2 minus 17.1s, that's our term, plus 136 T2 minus 17.1s, I've got 772.28 of these terms, T2 minus 17.1. So we've taken this term, added with that term to get that number right there. So we want to simplify a little bit more. What I'm going to recommend that we do is, okay, what we're going to do is divide both sides by 152.698. And on the left side, top cancels with bottom, and we're simply left with T2 minus 100. And on the right side, we have negative 5.057 T2 minus 17.1. So now we can just simply expand out this bracket, and then we're going to collect our like terms. So when we expand our right hand side, we end up with negative 5.057 T2s, and because we've got a negative and a negative, this becomes positive 86.48. So let's take our T2s and have them on the left side, and let's have our numbers on the right side. Okay, so we have 1 T2 plus 5.057 T2s. And when we add that together, we'll get 6.057 T2s. And on the right-hand side, 100 plus 86.48, 186.48. And now just some simple math. Divide both sides by the coefficient in front of T2. And this becomes a 1. And we have T2 is 186.48 divided by 6.057, which when rounded gives us 30.8 degrees Celsius. So that's our final answer. And if we go back up to the original question, we've got our piece of aluminum, which is placed into a cup, which is filled with water. When they've reached equilibrium, all three things will be at our final temperature of 30.8 degrees.